This video is about perfect numbers, Mersenne prime, and Fermat primes. The objective of this is to know and understand perfect numbers, Mersenne primes, and Fermat primes. Perfect numbers. What is a perfect number? According to the proposition of 36 of Book 9 of the Euclid's Elements, it states that if as many numbers as we place beginning from a unit be set out continuously in double proportion until the sum of all becomes a prime, and if the sum multiplied into the last makes some number, the product will be perfect. Example, we have 1 plus 2 plus 4 is equals to 7, which is prime. Then, multiply the sum and the last number, which is 7 times 4 is equals to 28, which is a perfect number. Another example is 1 plus 2 plus 4 plus 8 plus 16 is equals to 31. So 31 times 16 is equals to 496, which is a perfect number. Euclid's proof of proposition, known to Pythagoreans as 1 plus 2 plus 4 plus 2 raised to the power of k minus 1 is equals to 2 raised to the power of k minus 1. And the proposition now reads, for some k is greater than 1, 2 raised to the power of k minus 1 is prime, then 2 raised to the power of k minus 1 times 2 raised to the power of k minus 1 is a perfect number. Try to solve for the perfect numbers if k is equals to the following numbers. We have 2, 3, 5, 7, 13, 17, 19, and 31. And the results are the following. We have 6, 28, 496, 8,128, and we have 33,550,336, and so on and so forth. Nicomachus describes certain results concerning perfect numbers. We have, first, the nth perfect number has n digits. Second, all perfect numbers are even. Third, all perfect numbers end in 6 and 8 alternately. Fourth, we have Euclid's algorithm to generate perfect numbers will give all perfect numbers. Every perfect number is of the form 2 raised to the power of k minus 1 times 2 raised to the power of k minus 1 for some k is greater than 1, where 2 raised to the power of k minus 1 is prime. And the last is there are indefinitely many perfect numbers. Religious significance about perfect numbers. We have 6 is the number of days taken by God to create the world, and it was believed that the number was chosen by him because it was perfect. Again, God chose the next perfect number 28 for the number of days it takes the moon to travel around the earth. Saint Augustine also writes in his famous text, The City of God. It states that 6 a number perfect in itself, and that because God created all things in 6 days, rather, the converse is true. God created all things in 6 days because the number is perfect. You have also prime, Mersenne prime. A Mersenne number is a number that is equal to 1 less than the power of 2, or 2 raised to the power of n minus 1, where n is one of our selected positive prime number. Mersenne numbers, m sub n, are named after Marin Mersenne, a French monk. Mersenne asserted that in the preface of Cogitata Physica Mathematica in 1644 that for n is lesser than or equal to 257, m sub n is a prime number only for 2, 3, 5, 7, 13, 17, 19, 31, 67, 127, and 257. It is now known that for m sub n to be prime, n must be prime p, though not all m sub p are prime. Every Mersenne prime is associated with an even perfect number, an even number that is equal to the sum of all its divisors. Example, 6 is equals to 1 plus 2 plus 3. given by 2 raised to the power of n minus 1 times 2 raised to the power of n minus 1. For n prime, all known Mersenne numbers are square-free, which means that they have no repeated divisors. Example, 12 is equals to 2 times 3. Examples of Mersenne numbers are the following. 2 raised to the power of 2 minus 1 is equals to 3. 2 raised to the power of 3 minus 1 is equals to 7. 2 raised to the power of 5 minus 1 is equals to 31. 2 raised to the power of 7 minus 1 is equals to 127. Then 2 raised to the power of 13 minus 1 is equals to 8,191. Then 2 raised to the power of 17 minus 1 is equals to 131,071. And 2 raised to the power of 19 minus 1 is equals to 524,287. And the last is 2 raised to the power of 31 minus 1 is equals to 2,157,483,647. We have also Fermat primes. A Fermat prime is a Fermat number that is also a prime number. A Fermat number, f sub n, is the form 2 raised to the power of m plus 1, where m is the nth power of 2. That is, m is equals to 2 raised to the power of n, where n is an integer. To find the Fermat number f sub n for an integer n, you first find m is equals to 2 raised to the power of n, and then calculate 2 raised to the power of m plus 1. The term arises from the name of a 17th century French lawyer and mathematician, Pierre de Fermat, who first defined these numbers and noticed their significance. Fermat believed that all numbers of the above form are prime number. That is, that f sub n is prime for all integral values of n. This is indeed the case for n is equals to 0, n is equals to 1, n is equals to 3, and n is equals to 4. When n is equals to 0, m is equals to 2 is equals to 1. Therefore, f is equals to 2 raised to the power of 1 plus 1 is equals to 2 plus 1 is equals to 3, which is prime. When n is equals to 1, m is equals to 2 raised to the power of 1 is equals to 2. Therefore, f sub 1 is equals to 2 raised to the power of 2 plus 1 is equals to 4 plus 1 is equals to 5, which is prime. When n is equals to 2, m is equals to 2 raised to the power of 2 is equals to 4. Therefore, f sub 2 is equals to 2 raised to the power of 4 plus 1 is equals to 16 plus 1 is equals to 17, which is prime. When n is equals to 3, m is equals to 2 raised to the power of 3 is equals to 8. Therefore, f sub 3 is equals to 2 raised to the power of 8 plus 1 is equals to 256 plus 1 is equals to 257, which is prime. When n is equals to 4, m is equals to 2 raised to the power of 4, which is equals to 16. Therefore, f sub 4 is equals to 2 raised to the power of 16 plus 1 is equals to 65,536 plus 1 is equals to 65,537, which is prime. The search continues for Fermat numbers f sub n that are prime when n is greater than 4. Thank you for listening.